In this video, we're going to work through the practice questions for absolute value and imaginary numbers. Let's take a look at this first question where we're looking at the absolute value of 8 minus 2, and from that we're going to subtract the absolute value of 2 minus 8. So we need to evaluate what is inside each one of these absolute value brackets. And so 8 minus 2 just gives us the absolute value of 6. Minus 2 minus 8 is the absolute value of negative 6. And the absolute value of 6 gives us just 6. Remember, absolute value is the value of the number without regard to the sign. It's always going to be positive when you take the absolute value of a number. From that, we subtract the absolute value of minus 6, which just gives us 6. So 6 minus 6 is 0, and that is answer choice D. One thing that sometimes confuses people, though, they remember the definition of absolute value means you have a positive number. That's of this individual piece. The absolute value will always be positive. But when we have some kind of expression, which is made up of one or more absolute value expressions, the final result could be a negative, or it could be, like it is in this case, a 0. So just keep that in mind. It's not that you always have an answer that's positive, it's that a single absolute value will always result in a positive result. But then if you have some other operations to do, you have to consider that. So our answer here is D. Next, looking at question 2, what are the real solutions to the equation absolute value of x squared minus absolute value of x minus 6 equals 0? So this expression here looks very much like a quadratic. It is. If we saw it in the form x squared minus x minus 6, we know that we would factor, and that is one way that we can go to the answer. But I want to present to you another way here by using the answer choices. So we have answer choices F through K, and when we plug in these values, for whichever answer choice, when we plug in for x, we get 0, that's going to be our answer. So this might be a method that you may want to try as opposed to initially factoring. So if we begin with just F choice, that looks as easy as any of them. We have to plug in both positive and negative 2. That's what the plus or minus means. So if I plug in a positive 2 here, everywhere there's an x, I'm going to get the absolute value of 2 is 2, so that will be 2 squared, minus, again, 2, the absolute value of 2, minus 6, and that gives us 4 minus 2 minus 6, which is equal to 2 minus 6, which is equal to negative 4. That is not 0. So F option is out, just based on that positive 2. That's as far as we have to go. Now we could glance down at our other choices. If we had another answer choice that had a positive 2 in it, we could eliminate that, but we don't. So let's just move on to G, and let's begin with plugging in positive 3 everywhere there's an x. We're going to end up with 9 minus 3 minus 6, and that is 6 minus 6, which is 0. So far that works. We have to try negative 3. And if you'll notice, as we plug in a negative 3 everywhere there's an x, it's within an absolute value. So it's really the same as plugging in the 3. We're going to get the same result because the absolute value of a negative 3 is just positive 3. And again, we have 9 minus 3 minus 6, which again turns out to be 6 minus 6 is 0. So that is correct. For both positive and negative 3, we get a value of 0 for this expression. Now, I had alluded to the fact that we could use the quadratic up here, and if you had wanted to, you could factor this expression into x minus 3 and x plus 2 equals 0. And that would give us values of x to be x is equal to 3 and x is equal to negative 2. Now when we're dealing with absolute values, though, we have to check these values. And we also have to consider not only the result that we get when we factor, but also the negative of that, because you remember inside the absolute value could be a positive or negative, and you're still going to get a positive out of that. So we'd also have to check -3 and then +2. And so from this point right here, when you found these values, you would have to plug them in just like we've done when we were checking through our answer choices, and you would end up coming up with the +3 and -3 being the result that worked. So in this case, it may be just as easy to begin plugging in your answer choices, and you eliminate the step of having to factor the expression. But through practice, you're going to see how working this type of question works best for you. Let's take a look at number 3. If x is less than y, then the absolute value of x minus y is equivalent to which of the following? So this question, they did not give us real values to work with. In this case, I like to maybe use my own example test data points, and that's an easy way to look at some of this. So in our if statement, they tell us that x is less than y. So y is the larger number. I'm just going to choose a number. Let's say x is equal to 1 and y is equal to 5. That gives us the expression x is less than y, 1 is less than 5. So we're going to use these test data values, plug them in to the answer choices to see if we can eliminate any of our choices. So we know what we have to find is the absolute value of x minus y. And with the test data points we've got right now, we're doing the absolute value of 1 minus 5, which is the absolute value of -4, and that is equal to a +4. So we're going to check each one of these. So when I plug in choice A, 1 for x, 1 plus y, which is 5, I get 6. That's not the same as 4. So we can eliminate choice A. Now let's try choice B. We have a negative of the 1 plus x, the 1 plus 5. That's -6. Well, that's still not 4. So B is out. For now, I'm going to skip option C because it has a square root in it. We can handle square roots, but if I can, most people aren't as comfortable working with square roots, so for now I'm going to skip it. And if I come up with an answer that's correct, I don't even have to handle the square root. So let's do D choice, x minus y. So again, we used 1 minus 5, and that gives us a -4. Well, that we had +4, so D is out. And choice E, the only difference is they put a negative in front of the 1 minus 5, which gives us a -4, which is +4. Well, that matches what we have. So E is an option as an answer. Now, I say it's only an option. We're not 100% yes for sure, because when we chose our test data, we have to make sure we include all the different possibilities that it may be. In this case, there's two different routes we could go. We can go ahead and we can try to plug in to C, and if we can eliminate that right off, we know that E is the choice. Let's go ahead and try that. So if I have the square root of 1 minus 5, that's the square root of a -4, a negative number. And we know we can deal with imaginary numbers, but that is not the same as a +4. We know, so C is out. So that only leaves option E to be the correct choice. And we did get a correct value, one that matched up when we used two positive numbers. If we still had other choices available, we may need to look at, like, if x was equal to a -1, and we could still say y equal to 5, or we may even need to try if, let's say, x was equal to -5 and y is equal to -1, y is still larger. These are the different cases we may want to look at to make sure that for all cases of any test values that this statement is true, that the absolute value of x minus y is equivalent to the negative of x minus y. So in this case, we were able to go with the choice based on the others being eliminated. Again, we can always check these other values if we needed to. Let's take a look at number 4. The solution set of which of the following equations is the set of real numbers that are 3 units from -2? So let's just look on a number line to make sure we understand what we're talking about. We have a number line with -2 on it. 3 units to the right of -2 is going to give us a 1. 3 units to the left of -2 is a -5. So that's what we're looking at. We're looking at an expression with absolute value that will show this right here. So to me, what makes sense to do right now, one of the easiest things is to look at my answer choices, and let's try to plug in these different values that we have. And we can use the endpoints here, this -5 and 1, and let's just make sure they work for all cases. Let's just start with F. It really doesn't matter. None of the ones look easier than the other, except for, I do want to point out one. Let's look at option H first. It says when we take the absolute value of this expression, we're going to get a negative number. Does that ever happen? No. Whenever you take the absolute value of a number or expression, it's always going to be positive, so we can eliminate H. That's just something to observe. Now let's try to plug in. Let's plug in a -5 first. So if we get the absolute value of -5 plus 2, that's the absolute value of -3, which equals 3. That one works so far. Now let's plug in a +1, just to make sure we're getting both ends. Just like we did in number 3, we have to check the different values, positive, negatives, things like that. Now I'm going to plug in the 1. 1 plus 2. That equals the absolute value of 3, and that is 3, and that is correct. So right off, we can tell option F is going to be our answer. We didn't even have to try the others. But I do want to point this out because it could have been in a different order, and the correct answer could have been all the way down here at K. I want to show you something here and why we have to check both ends. If we look at option K, when I plug in the -5 plus 3, I get the absolute value of -2, and that's equal to 2. And so far that works. Now let's plug in the endpoint of 1. Absolute value of 1 plus 3 gives us the absolute value of 4, which is 4, and that's not equal to 2. So it does not work for all cases, this expression. F did work for our 2 endpoints, our 2 different extremes. So answer choice F here. Now we'll move on to our imaginary number questions, and let's look at number 5. It says for I squared equals -1. This is a property we had in our review slides that sometimes they'll give to us, sometimes they won't. They did here. They want to know what 6 minus I squared is equal to. So when I see a question like this, to me it's just easy to write both of these out here in this format, and let's multiply. And then we're just going to multiply using the full method, first times first, first times second, second times first, and second times second. So we'll get 6 times 6 is 36. 6 times -I is a -6I. -I times 6 is another -6I. And -I times -I gives us a positive I squared. As I'm working through this, I'm also glancing at my answer choices to see if my answer is already in one of the ones that they're given. It is not yet, because we'll notice we don't have an I squared in any of the answer choices, and they gave us this identity, this property. So let's use that. Let's simplify. We still have 36. We can combine -6I. -6I will give us -12I. And we know that I squared is equal to -1. And we can say 36 minus 1 gives us 35 minus 12I. And that's going to be answer choice D. That looks good. Now let's take a look at number 6. In the complex plane, the horizontal axis is called the real axis. We're talking about this right here. And the vertical axis is called the imaginary axis. The complex number a plus bi is graphed in the complex plane, comparable to the point AB graphed in the standard XY plane. So here are our complex numbers. They give us a definition here. The modulus of the complex number a plus bi is given by square root of a squared plus b squared. Which of the complex numbers, z1, z2, z3, z4, and z5 below, has the greatest modulus? So we reviewed modulus in our review slides for complex numbers. But maybe you have forgotten, but hey, we're in luck. They give us this definition right here. We know that it is equal to a squared plus b squared, where a complex number is defined as a plus bi. This is where we get a and b. It's the real component and the imaginary component. And we want this value, this overall value, to be the greatest. Which one of these z complex numbers does that result from? Well, it's going to be wherever when we take the a value and we square it, and we take the b value and square it, and we add them up and square root, it's the largest value, right? So since we are squaring the a and b, it does not matter if a or b is positive or negative, because remember, when you square a negative, let's say we have a negative 2, when I square negative 2, I get a positive 4. Well, and let's say we have the number 1. Let's compare these two. 1 is larger than negative 2, but when we square the values, it's the overall, it's really the absolute value of the number that we're concerned with, because when we square it, we lose the negative sign. So the point being, we are looking for the largest value without regard to the sign, and then when we add them up, that's what we're looking for. So if we look over here at our, this is going to be an observation question. We're looking here. We can start off by looking at the real axis, and on either side of our 0, 0, which values go out the farthest in both the positive and or negative axis? Well, z5 is out far, and z1, we don't know the exact values. They almost look the same, so we could almost say we're eliminating 2, 3, and 4 right now, because they are both, they have lower real axis values and imaginary axis values. So 2, 3, and 4 are out. We're down to just the difference between z1 and z5, which has the larger values. They're almost at a tie for real. Looking at their imaginary axis values, it's obvious that z1 has a larger b value than z5 is going to have. So that is going to result in the greatest modulus with the complex number z1. That's answer choice F.